On the next part of the project, you're going to do a hypothesis test. First thing you're going to need to do is to download your data set, go to Course Tools on Pearson, go to Document Sharing, and then click on Upload Data here and download your document. Once you're done with that, you're going to go to StatCrunch.com and you're going to enter the data in here. So click on Open StatCrunch, and then you're going to copy and paste your data set into StatCrunch. So hit anywhere in the Excel file, hit Control A, and that's going to select everything, Control C to copy it. And then you're going to go back into StatCrunch, click on Variable 1, and then hit Control V in order to paste it. So once you have this, you're going to go into Stat, you're going to go to T-Stats, then to Sample, and this is with the data. So because I have the original data, I'm going to click with the data. If you have a summary, so the mean, the standard deviation, the sample size, then you can click on this. But we're going to use the raw data. So click on with data. Sample 1 is going to be ARCO, and sample 2 is going to be Chevron, since that's the order that we had it in our file. The next part is going to do the hypothesis test. So we have to change this inequality sign to a less than, a greater than sign, or a not equal to, depending on what we believe is true based on ARCO and Chevron. So if you think that people spend more money at ARCO than they do at Chevron, then you would write it out. So for example, it would look something like this. I think that people spend more money at ARCO than they do at Chevron, and you'll test this at alpha equals 0.01. Make sure you make a reference to what alpha level you're going to test this at. And then I called sample 1 to be ARCO and sample 2 is Chevron, and then the claim is that the average amount of money, mu, that people spend at ARCO, sample 1, so subscript of 1, is greater than the average amount of money, so that's mu, that people spend at Chevron, so that was sample 2. So that's mu1 is bigger than mu2. The opposite of that would be that mu1 is less than or equal to mu2. So opposite of greater is less than or equal to. And then you would go and set up your null hypothesis and alternative hypothesis. So in the null hypothesis, we always have an equal. In the alternative, we copy the statement that does not have an equal. So mu1 is bigger than mu2. And then for the null hypothesis, we put a mu1 and then also put the mu2. So when you're typing this out, you would have to go and look for these symbols, the mu1 and the mu2. So we're not going to go and do that. We're actually going to let StatCrunch do that portion for us. So I'm going to go to StatCrunch, and then this inequality sign is going to end up being a greater than sign, so it has to match what we wrote down for the inequality. So this is greater than because we thought that they spent more money at ARCO than they did at Chevron. So then click on compute and don't change anything else from this. Don't change the confidence level here. That's only if you were doing a confidence interval. So hit compute, and then we can go ahead and copy and paste this. So we can select and drag and then copy and paste, or click anywhere in here, hit Control A, Control C, go back to the Word document, and then hit Control V. So that's going to paste the output from StatCrunch on here. So the next thing I'm going to do is I'm actually going to write out the claim statement, but algebraically. And again, because I don't want to go and type it out, what I'm going to do is I'm just going to copy and paste from StatCrunch the output onto this. So I'm going to hit select mu1 minus mu2, hit Control C, and then Control V to paste it, and I'm going to change that minus to a greater than sign. And then I'm going to also write down the opposite of this. So opposite of this would have been, so I pasted it again, and instead of the minus, I'm going to look for this symbol that has a less than or equal to. Since the opposite of greater it would be less than or equal to. Then my first step in the hypothesis test is going to be the null hypothesis and alternative. Just copy and paste this from the output. So hit Control V, Control C, and Control V. And you can leave it like that, or you can rewrite it so that it looks exactly the way that we would write it in class, with an equal sign between the mu1 and mu2, and the greater than sign in between the mu1 and mu2. Second step is to go and find the test statistic. Third step is to go and find the rejection region. And the last step is to go and find the conclusion. So for each of these, I'm going to go ahead and copy and paste the output from the StatCrunch. So test statistic was t equals, and then change this to the test statistic that was from the input, from the output. So 0.23, and so on. Copy this and then paste it for the test statistic. And you can use 4 numbers after the decimal if you wanted to, but it's not necessary. You can just go and copy and paste it. For the next portion, it's the rejection region. Because I have a p-value here already, might as well use a p-value. So I'm going to go ahead and use the p-value method, and I'm going to reject the null hypothesis if the p-value is less than alpha. So alpha is in the symbol, so go into insert symbol and then type in the alpha or select the alpha. So that means that I'm going to reject it if the p-value, which is 0.4061, is less than the alpha, and alpha we chose to be 0.01. So this alpha level is whatever you want to choose. You don't have to choose 0.01. You can choose 0.01, 0.05, or 0.10. So I'm going to put 0.01 in here. So we're going to check to see if this is true or if this is false. Let me actually also type out the p-value. The p-value was equal to 0.4061. So we're going to go ahead and state whether this is true or this is false. In class, we usually would cross it if it's not true, or we would leave it alone if it's true. So on this one, because it's not less than 0.01, this is false. So I'm going to write down that it was a false statement, and because it's a false statement, then that means do not reject the null hypothesis. If this was true, if this statement was true, then you say reject the null hypothesis. If it is not true, do not reject the null hypothesis. And then you write out your conclusion.